gotta first find out which one works. Okay, this one. Wow. Good. The first one.
Good, where's the?
Made with my hands. Not that good as my friend does.
It's good. Good. Okay, let's check the resistance.
Resistance, okay. Okay, I'm putting this here. I'm putting this here. Woohoo! Working.
Good.
Okay, so now we have.
What is the resistance almost?
Well, we go in here. It's 2 kilo ohm. We're talking about. Hold on. We go we go like that. We have a 41 ohm. 41 ohm.
Good.
41 ohm.
Yes.
Okay, and as a comparison, I can put it on a side and take this resistor. Okay, let's see what the resistance of this one. This is the resistor. Oh, that's 294. 294. 294. Okay, fine. And this would be then like that and like that. Okay. 43.
Good, good.
43 ohm.
4D ohm is good.
43 ohm.
Yes.
Okay. As a calibration compound, this one. Okay, so now we can put that here and try to apply it and see what's going to happen. Okay. I like it, the color. Okay. I like it. Okay. Now, the current that is drawn for the amplifier is 1.4 amp at 24.7 volt. Okay, I'm at 260 megahertz, and that band right now I start from 500 megahertz and go down like that, and the maximum power 5 watts. 30 watts is all together. Yeah, probably 10 watts. 400 megahertz, I don't see much response with that compound. So it looks like the frequency of response depends on each individual compound that you make. Depends how you make it accurate. Not much response. Not much response. So for the conductive compound, it looks like but we have a radiation level. Now it's going down, and with me, okay, I'm increasing right now the frequency 300 megahertz and going up. Okay, it's going, oops, so it rapidly goes up. Okay, I go less. Now is 260, 280, and I'm approaching 300 megahertz. 300 megahertz like in here. And now I'm looking at the radiation level. It's going all the way up. Okay, what's going on with the voltage? Not much voltage. Also getting a level of radiation right to the left. Right now I'm trying from 60 to 130. And this is the amplifier over there that is responsible for it. Unless I disconnect now, because the light is blinding the camera. This camera is a shitty camera. Okay, now we're changing, so we don't have much. We have a changing voltage on Colman. Right now I'm going to 130 megahertz, going back. It's less than 20 volts now. 110 megahertz, going down and scanning through all of the possible frequencies. And I'm wearing my LEDs. Okay, 13 volts, 14 volts, 57 volts, 61 volts. Well, definitely 150 something volts. Okay, definitely something is going on. Kind of nasty here. Okay.
What are you now?
I'm looking at the scale of Radiac light now. I don't want to show it in the camera. How much we're getting. But you have your balls protected, so don't worry about it. I have my balls protected as well.
What frequency you are now?
270 megahertz.
270.
Yeah. Well, that's
Optimum.
yeah, 84 volts. Okay. Now I'm slowing it down. 263 megahertz. That's what it is. The frequency of response.
Zero voltage.
Well, it shows 0 voltage, but it jumps to big one. We don't know what's going on over there. We just have a first time something that is sort of very much similar to the one that is supposed to be. Goes to amps. 2 amps, 2.6 amp, 2.5 amp, something like that. But it's nothing steady over there. Everything is changing. I'm gonna risk to put my hand over there. It looks like it's a little bit warmer than it was, but still it's not hot. It's very difficult to find that frequency for me, and I'm trying right now to get the record of that frequency. The frequency is marker, and how can I measure the frequency? Okay, there is the frequency, 450.9 megahertz. 450.9 megahertz. That's the frequency at which I'm getting gamma radiation. What next thing is happening is that after I switch everything off, gamma radiation, it will remain constant. That means it will still make the reaction. Now my friend says that normally it's not common that you can stop the gamma radiation. What he thinks is we're approaching something that is might be even worth the Nobel Prize. Anyhow, we have a frequency of 335 megahertz, 338 megahertz, and we have a hum right now from the speakers. Not able to show, but right now it shows that my Ranger is showing me the level. I don't know if that's gonna be visible. We're not getting much, but at least something. We're getting very little light.
The radioactivity level is
It's very low, or is big one? Kind of, okay. Okay, let's see if we're gonna get in another frequency. No. This was the frequency we were able to get something, not much, but at least a little. Okay. We know what we're getting. Okay, here. Not much. and the frequency is about 400 megahertz. Hold on. We have a very big reflected power. Okay, I can try to adjust that here. I can try to adjust that. Okay, look. See, I'm trying to adjust right now that. So we're having a very little light so far. Okay. How about this? Very little light. Very little light. So I'm gonna put it like that, switch it off. Okay. And we have very little light here. Not much at all. But at least we have a some effect. And of course the frequency is showing here, and there is something. Okay, and the frequency is 427.28 megahertz. I'm not very much satisfied with that, but at least something. Yes. You know what I'm saying? At least something. Let me switch the frequency. Go further with that. Okay. Okay, we have another peak here. Look. Okay, and now I'm gonna adjust that because the SWR is extremely small, bad one. Okay. Okay, so I don't have much, and I'm going to the next peak. Okay, now we have, look. In here is much better.
Oh, what was that?
There is the frequency in here, 319 megahertz. 319 megahertz, and the SWR is bad. Now I'm gonna try to tune it. Okay. Look at that.
Beautiful. How many watts you think?
3 watts, 4 watts, 3 watts maybe.
How much are we giving to the system?
We're giving about 28. Yeah, but look, we're giving 28, but come in here. Look, the SWR is bad, extremely bad. So if you look at this scales in here, you have a more of the reflected power than you're allowed to have. That's why we have this effect in here, but I can try to tune it and see if that helps anything. Let me go to further the frequency, any other frequency. Let's see what we're gonna have. We're getting some response. Okay, yeah, that's what we have. Okay, that's what we have in here. Okay, that's the previous frequency that we have had. That's another one. That's the another one. I can change it again. See what we're gonna have here. Nothing at all. This is not with SWR, but the light bulb is not giving us anything. Okay. Well, at least some kind of response, not much.
Yes.
Okay. So the activity is off. It is still showing. So what I did is I put a switch on. Okay, see here, and count seconds. I'm gonna put 4 seconds. Okay, this goes up 1, 2, 3, 4, 5. 5 seconds. Still didn't return. Still is holding. Still didn't return. Now it's a little bit returning, but very slowly. It's holding. There you go. There you go. It's still holding. Okay. There you go. Now the power is off. Power is off. Okay, it's kicking back a little bit. Now I'm gonna switch off the power on this. Kicking back. Supposed to be 0. Still holding, and it's growing up. That's the proof. We had that little light bulb. This one didn't work, but we had this one, and this one burned up. I've checked it out. It was so bright, so it didn't burn up. And inside we have that tube, and I put on the top of it my gamma radiation. This part could be stripped or say omitted by you, as is strictly related to theory. As you see, vacuum is in between the bonds of an atom, and the vacuum is also inside an atom structure. If we take, for example, carbon atom, we see 1, 2, 3, 4, 5, 6, 7. 7 protons. Let's count. 1, 2, 3, 4, 5, 6. 6 neutrons. And then we have something that is with the minus, which is neutron pair. We're not gonna go into it. What you want to know is the neutron barrier holds protons in and keeps electrons out. Well, there's a mutual attraction between the proton and electron, as proton is positive and electron is negative. We also have a number of orbits which are occupied by 1 or more electrons. So the more far electron is from any plane, it does have a higher energy level. And of course, when it falls down, it loses the energy. We have 3, we have a 4th beryllium, and then we have another orbits. And go further. We might be interested with cobalt, but not cobalt 27, cobalt 59, cobalt 60. Although we use non-radioactive one. And here is where the cobalt is on the periodic table of Mr. Mendeleev. Not everybody remember that. There was a Russian guy. The nuclear structure of a cobalt. The interesting part is that I was trying to assign nuclear magnetic resonance to the phenomena from Lithuanian experiment, and I was also looking for the same explanation in ACUA over Unity device. which is sort of similar to Tariel Capenazza, but we cannot really distinguish differences or similarities. So let's go to cobalt 59, nuclear magnetic resonance. Okay. 59 is a nuclear spin 7, 2 and 100% abundancy, and the nucleus has magnetic quadrupole moment. Among all of NMR active nuclei, 59 cobalt has the largest chemical shift range, and chemical shift can be correlated with the spectrochemical series. Resonances are observed over the range of 20,000 parts per million, the wave of the signal being up to 20 kilohertz. For my friends from Unity, look at that. A widely used standard in potassium hexacyanocobaltite which is due to its high symmetry has rather small line width. System of low symmetry can yield broadened signals to extent that renders the signal unobservable in fluid phase nuclear magnetic resonance. In those cases, signals can still be observable in solid state nuclear magnetic resonance. Well, just recall ferrite from the old CRT group in Russian that somehow correspond with cobalt 59 present to 1959 Colman free energy device. And of course, as I said, my suspicion is that Andrea Rossi, who is changing the primary fundamental particles, nickel to copper, is using cobalt as a secret ingredient in it. When you're talking about vacuum in the bonds of an atom and vacuum in the atom by itself, it looks like it's a very, very much comfortable explanation for why this thing is turning. So, if there is a vacuum, due to the Newton law, body put in motion, stay in motion, and although it's vulnerable to the external influences, it turns. That's what it is. Another question that will arise is, if it turns, who gave it a very first motion? That would be kind of explanation to the God. And that is also going to be my next video, mostly theoretical, key to become a God. With all due respect to all of the believers, I'm rather having a conversation of the power of the God, the power of creation. And the discovery that I have made, if I made one, because that is questionable, of where is the key to creation, directly related to this particular experiment. So most of elements in periodic table can be found in nature in more than one isotopic form. By definition, all of the isotopes of the particle element contain the same characteristic number of protons in their nuclei, but they differ in the number of neutrons. A listing of all known isotopes of the elements is referred as the table of nucleides. Some of the nuclei are unstable. Over the time, the individual atoms will change form by releasing matter or energy from the nuclei. The process for release of the matter and energy are called radioactivity. Now we have in here what? the matter to energy, mass to energy, energy to mass conversion. Okay. But if we think about it in micro scale, not macro scale, micro scale, each radionuclide undergoes change, or say decay, through the sequence of events called decay scheme. So since products of decay are characteristic of the nuclide, and the decay process, it is the process of decay that must be detected and qualified in order to specify or monitor a compound containing a particle radionuclide. And that's what I'm trying to do. I'm trying to see what do we have there and how that energy exchange looks like. Matter is released from unstable nuclei as subatomic particle. Photons, neutrons, positrons, negatrons. The negatrons are beta particles. Alpha particles and neutrinos are, I would say, less exotic or commonly released particles. Energy released from decaying nuclei can take one of two forms. There are two different forms. One of the forms is associated with the particles that are released and is directly related to their kinetic energy. Particles with greater kinetic energy carry away more energy from the nucleus than particles with less kinetic energy. So what would be the other form? Well, the other form would be energy is the other form of energy would be that the photon is, which has either no mass or no charge. So the one of the property of the photon is no mass, no charge. Originates or has its origin in nucleus. So nucleus now says, I don't like something, something is, uncomfortable. And that manifestation of energy exchange would be then photon, but that photon will belong to gamma ray, or in other words called gamma photon. Well, we can take one of the atoms, say carbon 14, or say H3, or say P32. During beta decay, one neutron disappears and another additional proton appears in the nucleus. At the same time, two particles, a negatron and neutrino, actually there will be antineutrino, right, ejected from the nucleus and escape from an atom at high velocity. There you go, energy exchange. The manifestation could be an X-ray. But the question then is, where the heck the proton came from? And why do we have a additional neutron that disappears? What the heck is going on with it? So there are plenty of questions. We could go further with that and say that a negatron beta, which beta particle is minus, so it's negative, has a single negative charge and approximately the same mass as an electron. So what little ability negatrons or beta particles have for penetrating matter is directly related to their energy. So if there is a low level of energy, they don't penetrate that much. Also from the safety reasons of me experimenting with it. So there are well-established techniques for detecting and presence of the energy of those particles, and that's what I am using is a scintillating scintillation counting in order for me to find out what am I having. I do have an X-ray meter, I have a beta meter, I have an alpha, or sort of alpha ability to measure, and gamma and neutron. So if still I'm getting something, it's puzzling. Good. Cannot measure protons. Or maybe somebody knows how can I do it. Anyhow, the total energy released from the particle nucleus during the beta decay is a constant and is characteristic of the particle nuclide. As a matter of fact, talking about neutrino has no charge and vanishing little mass. So neutrinos are able to penetrate the Earth without being detected from their cores. So as a result, it is extremely difficult to detect the presence or quantify the energy of the neutrino as it escapes from an atom during beta decay. So they are not used at the same basis for monitoring beta decay. Question is, what are we talking about? Are we talking about methods of measurement and protecting my bag? Or are we talking about energy exchange? Or we're talking about how to become a god, or say have ability to create. Those subjects will be the part of the next video, as I stated before, and it's gonna be sort of revelation. From the beginning, I state that I do have a big respect to every religion and everybody. It is just that imagine that you have on your own desk a tool to create. Well, many people would say, hey, I want to create a gold. It's not about the gold. I don't care about it. But yes, might be possible. Anyhow, I'm gonna leave you guys, and thank you very much for spending time with me. We have had sort of result, that means we've got an electricity. There is of course a need for further investigation to find out how we can get that 1.1 kilowatt of power from 45 millimeters long quartz tube with Colman compound and 5 millimeters in diameter inside. Definitely from the instrument, it looks like that we have a decay after everything is switched off. Now from the legal point, that's another story. Well, the legal point is, and it has to be supported, I do not advise anyone to play with this technology, and I'm not responsible for anyone trying to play with it. A simple statement would be never play with it ever. All of the side effects is my interpretation of what might have happened, if it happens at all. But it does not make any proof of past or future results admissible in front of court or any legal institutions or authorities. Period. Term my interpretation is based on my ability to understand, interpret, and describe any phenomena and facts, and does not make it free of errors. I was not born with English, so that might be a big difference between what I understand and what you or anyone understand of what I say. I use 100% non-radioactive components in my scientific proceedings, say experiments. So by that, based on the official science, it is in direct conflict with the physics that non-radioactive matter could be turned into radioactive one using this method. If one wants to legally accuse me on something, at first one must prove that science of physics is wrong. That by itself is a revolution of its own, and that will be an official validation of Colman patent. So why am I telling you all of that? Well, the reason for that is that there is a plenty of power or plenty of people. They don't like you guys, they like me guys, but they like their own big oil money or energy money, and those are just waiting like a hyenas to bite you or bite me. Anyhow, everything what I said before, what I did before, is my own interpretation. So thank you guys, and if you, thank you, right? The other guys,